For this next step in our workshop, we are going to be writing, testing, and deploying an ERC20 token to Polygon using Vyper. And in particular, we'll be using Vyper's module system, which is great for code reusability and is going to allow us to write a very slim contract very easily. If you look here, this is token.vy, right, in the repo, and it's about 20 lines of code with plenty of white space. So using Vyper's modules, it's really easy to deploy standard contract with very little code. But let's go step by step over the different parts of the contract. All right, so to start, what you'll always have is going to be your pragma with your compiler version. All right, so here, since we're going to use modules, we have to use 0.4.0 or above, since this is the version in which modules were introduced, right? And then below your pragma, you've got other fields for your license. You can add an author field if you want, a description, any others, right? And you do that again by using, you'll recognize here, Python's comment syntax, right? Which you want to use before adding any further information. And then from line 4 on, here are our imports. So again, here you'll recognize that the syntax is exactly the same as Python's. When you're importing packages in Python's, you use this from blah, 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 import module. Right, so in Vyper, we're doing the same, but here we're importing from Snekmate, which, if you remember, is the library that we've installed through Moccasin when we were setting up our dev environment. Right? And so here we are importing it, and then at compile time, the compiler is going to resolve it, resolve the modules, and integrate them into our contract. So what we're importing is Ownable, which is going to enable us to do some access management on our ERC20 token, define an owner that can mint more of the supply, right, with some rate management. And ERC20, which is going to be a module that implements all of the necessary functions to match the ERC20 standard for a token, right? So next step is initializing our modules. So here, initialize is ownable, right? Means that, well, it allows us to ensure that this module, ownable, right, its state can be accessed and modified. Same thing for ERC20, but here we are adding something more. ERC20, right here within the brackets with the walrus operator, we are defining a dependency for ERC20 on the ownable module that we have just initialized. So this is here, the walrus operator is used to declare that this ERC20 module that we are going to use depends on the state of the ownable module. Right. So this is necessary because our ERC20, right, this is what we want to use the access management for. Right. So it's going to need the usable, the ownable module. And after initializing, we have exports. So exports, the export statement explicitly states what specific functions or interfaces should be exposed. Right? So external functions from modules by default in Vyper are not going to be exposed in the importing contract. So that means here, ERC20.owner, right? I'm exporting it. So this is a public variable, so it would be available. But the mint function, for example, here, I am exporting it. That means that the ERC20 contract that I'm going to deploy is going to have that function available. If I did not export it, right, ERC20.mint, there would be no publicly available mint function on the deploy contract. Right. So obviously we want to be able to mint token. We want to be able maybe to change the address that's allowed to mint those contracts. Right? And obviously we also want all of the standard ERC20 functions to be available, like transfer, approve, right? Symbol to get the symbol or the decimals of the token. Right? And all of those would be in the interfaces here that we are also exporting to make sure that all of those are available in our final contracts that uses those modules. Right. The last step here is going to be initializing our contract. So in it here, again, very Pythonic syntax. You'll be familiar with it from Python classes. And you'll notice here that we've got a decorator. So again, this is very, this is straight from Python. Vyper has a few decorators that act pretty much the same as they do in Python. They allow you to explicitly state, right, to modify the function below. So deploy is only used for a function that is called at deploy time, right? So the init function here definitely fits the description, but you can have other, if we were declaring another function that we wanted to be publicly available, then we would make it external, right? I don't know, here, get x, which returns, right, something like this. So external. If we want to make this an internal function, right, so something that can only be called within the contract, we would use internal. If here, this function actually does not access the contract state or any environment variable, so this is actually a pure function. And we could signal this by adding the pure decorator. Right. Obviously, it's also a view function since it does not alter the state. So we could add a view decorator. If we want the function to be able to receive ETH, then we can make it payable. And finally, we have the non-reentrant decorator that allows you to protect your contract against reentrancy attacks. Right, so those are all the decorators, but here we're only going to use the deploy one, right? Because the init function is going to be called at deploy time. Right, so init, and then once within this function, we need to initialize our modules, right? So because the first module that we're going to be using is ownable because ERC20 depends on it, right? We're going to initialize ownable first, and there are no constructor arguments to ownable, right? It's only whoever deploys it, right, is going to be the owner by default. We can actually check this by looking, right, if you're unsure as to how a module actually works, you could go to Snekmate, either on the GitHub repo, but we have it here in our repo since we've installed it. And I think this will be in oath. Right? And here we've got the ownable contract. Right? And so we can check that indeed here the init function, the constructor, right, does not need any arguments. Instead, it will give ownership of the contract to whoever calls it, right? So to msg.sender. Right, so once ownable is initialized, we can initialize our ERC20 module as well. But here we do need to pass a number of arguments, which we again can retrieve by simply going into Snekmate, opening the ERC20 module. Right, and here we can get the full docstring for the constructor. And we see that we'll need a name, a symbol, decimals, name EIP 712 version, and this is it. And you might want to be careful as the strings here have a max number of characters. All right, so this is what we do here. We give our coin our token a name. We're going to call it my meme coin. This is the ticker, the symbol, 18 decimals, and those are the EIP712 harems. And this is it. We have got all that we need. When we deploy this contract, it's going to automatically have all of the functions here that we've exported from the module. Right, so this allows us to have composability. Right? Instead of inheriting from an ERC20 contract the way that you would in Solidity, you are able to select exactly what you want to export from those modules. Right. So now, how will we make sure that this contract actually works? Well, what we would do is write a test for it, right? And the good thing with Moccasin and with Vyper is that you can test out your contracts by writing your test in Python. And you can reuse pytest, which is probably the most popular testing framework for Python. You can use pytest to test out your Vyper contract. So here, if we go to conf test, right, this is where you usually set up your pytest fixtures, which are like basically all of your reusable elements for your tests, right? So here in pytest.fixture, we can define token, which is going to be a Vyper contract, and is going to deploy our token contract. So the name of the contract here is defined by, it's just based on the file name for the contract. So we've called our contract token.vy, right? And so we can use this here when we want to deploy it. We simply refer to it by name. We need to import it. All right, so here from SRC, which is the folder in which we've got all of our contracts, we've imported the token contract. So here it's imported, and Moccasin is going to ensure that the file, the contract, the Vyper contract, is properly resolved when we deploy it. All right, so here, this fixture, so this is, all of the tests are going to be happening on a toy EVM. Right? So we can fork the Polygon network if we want to test on a live sort of environment. But for this, we don't really need to interact with any other contracts. So any toy EVM will do the trick. And so this is going to be by default in Moccasin. We're going to be using this. It will also be slightly faster. So here we're deploying the contract. And next in our test token file, we can actually create a test function, right, that will reuse our fixture here. And we can make sure that the token that we've deployed actually has the name and the symbol that we have given to it. Right. We could do more. We could actually test out some of the right, like the transfer function or the approve function, but it's not. Maybe it's not necessary, right? Because the all of those functions, maybe we want to make sure that we've properly exported them, but all of those functions have actually already been thoroughly tested as part of Snekmate. Right. So here, test token deployment. Right, the token has been deployed in the fixture, and we want to make sure that the name and the symbols are right. And so right, we can run here. I'll do it from within PyCharm. We can run the test. So we are going to call Moccasin test. And then here we're going to specify, right, we only want to run one of the tests. We've got more in the same folder, but we don't need to look at that just yet. Right, so here, make sure you select module and not script for Moccasin, and test /test.test.token. Right. And of course, you can also do that from the command line if you're more comfortable with it, but I'll just stay with the within PyCharm for now. Right. And so here, test token, our test has passed. So our contract has been successfully written. Right. So now that our contract works, we might want to deploy it. And to do so, right, we can also do this with Moccasin using a deploy script. So here, We can actually there is a deploy command. We can do deploy token and then specify the network, but we are going to use a deployment script. Right? A deployment script allows you to be a bit more specific about what you want to do, a little bit more flexible as well. So here, when we do run deploy network polygon, what Moccasin is going to do is it's going to look in your script folder here for deploy.py, right? And then here, Moccasin main is what it's going to be executing. Right, so here, if you have the default version, if you just clone the repo, it's going to be deploy. We'll change this to deploy token only, which is simply going to deploy our token contract right here, which will give you our meme coin. Right, so token.deploy, that's all it takes. Of course, you need your imports. Right, so from SRC, we're going to import our token contract. Then all we need to do to deploy it is create a function that runs token.deploy. Once this is done, right, we run Moccasin to deploy it, and we're going to deploy it to Polygon. Right. The deployment assumes that your network is properly configured in moccasin.toml here. But if you've cloned the repo, right, hopefully this should be good. And if you have your environment variables properly set up. All right, so we can run this. Moccasin here is going to warn us that this is an actual deployment to an actual network. And so it's going to cost us actual gas to deploy the contract, but we're fine with this. And here, right, if you remember in moccasin.toml, we've specified an account. And this account is going to be paying for the gas to deploy the contract. Right, so here, just enter your password. And Moccasin is going to deploy it for us. Our transaction has been broadcasted and the contract is deployed. And here we get the address, so we can go and check it out in the Block Explorer. You can actually add a parameter here if you want your contract to be automatically verified by Moccasin. I'm not sure I did this, and I'm not sure if it's by default. But in any case, there is an option to also automatically verify your contract. And so this is it. Our token is up and running. We could actually go to a Block Explorer and check it out.